Good morning. Welcome to Introduction to Woodworking for Inventor. I'm your presenter, Carl Royan. I'm an application engineer with Micrographics. Today we're going to be having a look at Woodwork for Inventor, high-level overview of what it is and what you can do with it and kind of who it's aimed at. So let's have a look here at the agenda. We'll have a discussion, 30 to 40 minutes, and we're going to talk about the Woodwork for Inventor, what Woodwork for Inventor is, the benefits of Woodwork for Inventor, and have a look at its workflow. We'll then have a hands-on demo, and where we'll look at that workflow, see how much time we have looking at materials and bill of materials, and then we will move on to a quick summary and Q&A session. So starting off with the discussion, it's always good to get an idea of the environment or what you're designing for, should I say. So when you're looking at woodworking, I think it's a good idea to highlight the use of materials and hardware when working with designs in wood. And when you're looking at materials specifically, they are multifaceted. You've got your core material that could be a chipboard or MDF board. That material then gets faces laminated onto it. So you've got your veneer or your formica faces that are laminated. And then that usually gets trimmed to size and edged. So these materials, the single board is actually an assembly in a way. And we need to know how can Inventor handle that versus how does Woodwork for Inventor handle it. This material, this board could have many styles. The veneer could be different colors. The edging can be different colors or wood grain edging. And so we can change those styles and also the combinations of those styles to suit the customer's requirements on the look and feel that they want for their furniture. We need to consider the thicknesses of these layers. You have a 16 millimeter core, and then you add on a 1 millimeter thick veneer onto each side. You end up with the overall thickness of 18. So how does Woodwork for Inventor consider those thickness changes? And also if you're adding on edge banding, especially if you're using something like impact edging, you're adding 2 millimeters on either side of the panel. And we have to look at finished size versus cut size of those panels. And we also need to account for grain direction. Obviously, when cutting on the CNC, grain direction is going to be important. And for the final look and feel of your design. And then we talk about accounting for oversizing, and certain processes will need the board to be oversized and then cut down to the final required size. So we can look at accounting for oversizing as well. So the image on the right-hand side here kind of shows Inventor, shows what in Inventor a single part file, but in Woodwork for Inventor, that part file, that panel can include your workpiece and your various cover pieces on the outside. Then with woodworking, we have to look at hardware as well, and the different types of hardware we can use when creating furniture. We have different ways of creating joints using pins and cams. We could use dowels and dominoes, hinges, screws. Also, obviously, the inclusion of handles on doors, holders, supports, and legs. All of these things need specific hole patterns drilled for them to be able to mount to the furniture. And we'll have a look at how Woodwork for Inventor takes that into account and makes that process a lot easier, creating those holes. We can see the pins, the holes for the pins in the cam in the wood on the right-hand side. We'll look at how Woodwork for Inventor generates those holes from the hardware that is inserted. Now, to look at the workflow from an inventor's perspective, Inventor is capable of doing woodwork design, but it's not specialized for it. If we spoke about that panel with the core material of chipboard and then the veneers on either side. If you had to do that in Inventor, you would have to draw the core panel. You would then have to draw the piece of veneer that would go on top. You would then have to draw each piece of edge banding that goes around that. So a simple panel you'll end up needing to draw 7 different parts. You've got your 4 sides, let's assume it's a square panel, your 4 sides with the edge banding, your veneer top and bottom, and your core piece. And so that'll be very time consuming to do that. And the workflow from there is, you'd be doing your 3D modeling, your shaping and your planning, and generating your drawings, your layouts, arrangements. And this is one thing with Inventor as well. There's no specific tool set for marking on those drawings, things like grain direction, edge banding. You would have to go and create your own symbols and build up your own symbol library for being able to identify those specific things on a drawing. The bill of material, once again, to get that complete bill of material, you have to draw every single component individually. You can't draw a panel and then have that single part file broken down into veneer and edge banding. And then when it comes to manufacturing, your CAM, creating your CAM toolpaths, Inventor, if you're getting the collection, the product design and manufacturing collection, you do get CAM tools built with that collection. However, they don't consider woodwork specific machining. It's more looking at machining of metals. So your woodwork specific machining tools may have or would have things like horizontal drilling of holes, and that's very difficult to achieve using Inventor and Inventor CAM. So that being said, Inventor is a good solution, but it's not built specifically for woodworking. So Chailey Apps came in and they decided they were going to build an add-in that bolts on top of Inventor and is developed specifically for woodworking. So what does it do? It bolts into Inventor. It's an add-on for Inventor, and it provides a specific tool set that is directly integrated with Inventor, and that tool set is specific for woodworking. So these tools include some added shell or parametric modeling. So when it comes to modeling up, they're taking advantage of what Inventor has, but building on top of that for parametric modeling. It's got better material handling, where we can apply your veneers, edge banding onto a single panel. It has specialized bombs. It draws up its own bill of materials. It doesn't use Inventor's bill of materials. And this allows you to actually customize the bill of materials that get pulled out quite a lot. And you can pull out various different bill of materials. It includes iBox technology. We'll have a look at iBox technology at a later slide, but this is proprietary information that allows to reuse a design quite quickly and easily. It has auto-plot options for drawings, so you can generate drawings quite quickly and easily using an automated process. And it also has built-in CAM technology. That would be if you buy Woodwork for Inventor with CAM. And that includes CAM technology, which also allows you to automatically output programs for your files. And the purpose of Woodwork for Inventor is to reduce the amount of design time and improve your efficiency and ease the design of woodworking products, as they're different to other sort of more traditional manufacturing processes where you're looking at machining of metals, welding, industrial machinery design. So it's giving you a more targeted tool set for woodworking. Now, what are the benefits if you're using Woodwork for Inventor? The benefits of that is that you are working with a modeling process or procedure that is designed around woodworking. It's focused on repetitive products. So if we have a look at tables, desks, drawers, kitchen cabinets, they can all have the same layout, look, and feel, but you could reproduce them in various sizes. The construction remains the same. Kitchen cabinetry is a good example of this. because your kitchen cabinets can change width. You can have a standard width, but to fill the end, you need a new custom width to fit that required space. Its material handling is superior. You can quite easily and quickly change out the facade materials that are shown, your veneer, your edge banding. You can quite easily switch out for different colors. And this leads us to the focus on variation. You can have a standard desk that is sold, but you can have different variants where your styles and combinations of materials and hardware changes depending on customer requirements. So you can sell a red desk today, but you can sell a mahogany desk tomorrow quite easily by changing the materials in the design. And then we spoke a little bit earlier, the hardware is unique to woodworking. We've got the dowels and hinges and joints, etc. Woodwork for Inventor has specific tools for dealing with hardware, inserting hardware, and also drilling out the required holes for the hardware. If you look at a hinge, you can create the pot in the door as well as the pilot holes for the screws. And then the cam requirements here look specifically at, let's say, the length of the board and decide on how to place that into the machine your pockets and grooves, holes, specifically horizontal drilling. And once again, your designs can be custom fitted to your space requirements. So those would be the advantages of using Woodwork for Inventor. And on the right-hand side here, we can see there's a bit of a workflow, design, bomb, drawings, and CNC. And then there is a custom kitchen cabinet there. You can see some quite complex angles built in there as well. So if we look at the workflow, where we're going to take advantage of specialized tools to handle the woodworking designs, we start off in the design phase with spatial planning. This is where you're going to essentially design out the space and where your cabinetry, in the case of, let's say, a kitchen, where your cabinetry would go. This allows you to then insert eye boxes or create your own custom cabinetry or furniture, apply materials, and add your hardware. From there, you can extract your bill of materials in various formats. I've just listed a few here: cutting lists, your picking lists for, let's say, stores to pick out hardware required for a job, raw materials, so you can get a summary of the total raw materials required, as well as, let's say, any consumables that would essentially fall under your picking list as well. Drawings, there is automated output for drawings. These can be predefined on a drawing template and then essentially go through each part or assembly and have those drawings automatically output. The user would then just need to go back in after the fact and just neaten up the drawing. There's no need to place in all of views, dimensions, notes that's automatically put in. And then going to manufacture, the automated output of the CAM programs. And that works in a similar fashion to drawing outputs. You predefine what you need, and the program will then work on priority to then create that CAM program. So if we start at the beginning of that workflow and we look at spatial planning, we, in this case, are looking at a simple carcass. And the spatial requirement for the carcass is that blue box in the first image on the top left-hand side. So that is the space we need to fill with a custom cabinet. Then going on to the second step where we've got the red faces that are highlighted, that is adding on the panels. So you select each of those faces and those panels are added to those faces in the direction specified with a specified thickness. So then the end result is the third image on the right-hand side there with the box with the final panels added to it. However, those panels are full height, full width, full depth, so the corners overlap. Then we look at specific modification tools to help now to trim and shape and modify those panels to fit. So we can see on the first image there on the left-hand side, the blue panel is selected, and the top panel is selected, that's in blue, and the two side panels selected in red. So those side panels will be trimmed to match that top panel. You can see in the second image there with the trimming. The same can be done with miter. You can select two panels and have the corner mitered where they are overlapping. And one of the other modification tools is clone. This allows you to take an existing panel, let's say at the bottom of this cabinet, and clone it and shift it up. You're essentially offsetting it upwards to create a shelf within the panel. So you can clone that, create a shelf, and then once again use the trim function to trim the shelf to fit within part of that cabinet. So we've got these tools to quickly create a custom box. From there, you can add hardware. So you can use Woodwork for Inventor's hardware-specific insertion tool to basically select 3 faces to insert your hardware. If I use a hinge as an example, you would select the inside face of the cabinet where the hinge is going to mount. You would select the front edge of that board, and then a work plane that would specify the height of the hinge, so the mid plane for the height of the hinge. Those 3 faces are then used to attach that hinge to your hardware, and you can, or to your cabinet. And you can do this for multiple hinges, 3, 4, 5 hinges at once. And we're talking about the holes that the hinge might require a little earlier on with the hardware. And there's a sculpt tool built into Woodwork for Inventor where that hardware will have a negative space that's required. In the case of a hinge, you need that pot drilled into the door. So the hardware itself has a negative space that will represent that pot. And the sculpt tool cuts that negative space out of the door itself. And we can see there on the left-hand side, we've got the pots drilled into the door. On the image on the bottom right, there are holes drilled for the dowels that were inserted into the assembly. So the sculpt tool finds the hardware, finds that negative space in the hardware and removes it from any material that is overlapping with that. So this creates the hole drilling quite quickly and easily for your panels. Moving further on with hardware, you can also create your own hardware. So you can take hardware from a supplier's catalog, either download the model, put it into the library, or even model up your own using R parts. So in the case here of the handle, we have a handle which has an R part family, and this will specify the pitch between centers on the screw. So we can easily choose the next option available and have that handle update to the required length, as well as even screw length according to panel thickness. So you can build in your own hardware into the software's libraries as well. Now, once you have your cabinet, in this case, just a simple carcass for it's a cabinet, kitchen cabinet with the door and the handles and the hinges, you can go ahead and apply your materials. Now, with this, you're essentially applying a color scheme. You're applying a certain material type to the carcass and then maybe a different material type to the door. So we can see here in the material assignment dialog box, at the top, we have options for selecting, filtering, and also setting whether or not the material is on top of that carcass or is it sunken in, so that we have to remove any material to place in the material. Then we have multiple material types. At the moment, edge band is selected, but you can choose your veneer, your laminates, paint, your various different types of materials that can be added. And then at the bottom there, we can see the available material, the materials there. So we've got PVC edge banding in various colors. We have veneer in various colors. And so those can be applied, and you'll see there's a color code for them as well. The idea here is that you are essentially just placing in a placeholder for now on what the colors or where the color separation will be. The carcass is a different color to the door, essentially. So now if this cabinet that you've created is going to be something that is reused multiple times, you can generate what is called an R-box out of that cabinet. Now, if we look at the R-box technology here, essentially you can take that cabinet and author it as an R-box. So there will be some input that's required by the user. and that is generally going to be a couple of eye mates that give you top, side, and front position of the box. And once you've authored an eye box or use an existing eye box, you can then take that box and place it down onto those blue, we call them skeletal boxes, to position each box, and it will automatically resize according to the selected faces on that skeletal box that you're using. So we can see here the eye box on the left-hand side has been placed down onto 3 other boxes of different sizes, and the end result is that that box is duplicated and resized to fit each one. So if this was a kitchen cabinet, you would be applying this box to, or this carcass to, skeletal boxes of various sizes within the kitchen and having it automatically resized for each one. Going a little bit deeper into this, what you can actually do is you can have this eye box have a little bit of logic built into this eye box, so that if the door height extends past a certain value, the handle then updates to the next length handle. So there is a little bit of functionality that can be built into there with our logic as well. You can see in the image on the bottom right-hand side here, there is the option to insert and refresh eye boxes within Woodwork For Inventor. Then we move on to the bill of materials. So the benefits here of the bill of materials is that we've got that superior material handling, and we can also essentially take a color scheme as we see here in images, and we can do material and hardware replacements for quick variations and changes of that. So you can say, okay, let's say that the facade here is a certain color. We can do a material replacement and replace that out with a different set of colors. And so you can have a standard design, but when you output the bill of materials, you choose that you want to output to a specific replacement of color. So this design here is being output either as a just a natural wood finish, or it can be output as a painted finish. And that painted finish could even be changed so that you have various colors, red, blue, green. And then those bombs can be saved and merged to generate a much larger bomb for, let's say, a larger project like a bank or a school, or a apartment block where similar designs are used across multiple apartments. So that is the benefit there with the woodworking bomb. It's quite easy to switch out those materials. Even with the hardware, you can have a certain handle type, and as long as you are switching out to the same pitch handle, you can quite easily do a hardware replacement to replace just a standard generic handle with a handle that has the same pitch but of any other style. So you can go for a more ornate handle, you can go for something that's more modern. So when you're exporting your bill of materials, you can do that hardware replacement and replace cheaper generic handles with something, let's say, more expensive to the customer's requirements. And if we have a further look at the bill of materials here, the bill of materials understands Woodworking For Inventor's way of modeling. So it can break down that single part file. If we look on the right-hand side here, there is the drawing cabinet 3_01. That's broken down into different workpieces, the core material, the veneers. If we actually click the plus sign and expand that out, it would list the veneers and the core materials that are used on that panel. So it can take that single part file in Inventor and actually break it down into a bill of materials. So it understands how those veneers and edge bandings and finishes are added onto that core material. And this BOM can then be output to Excel in multiple styles using the BOM template. So you can output a bill of materials that will show the assembly structure, the cutting list. It can show a list for stores or for an ERP import so that you can capture information into your resource planning software. If I advance this over, we can see here is an example of one of the bill of materials, and we can see here that if I look at the very top item here, name is top. It's got a material code, material name, there's a coloring code. But more interesting, if we look at the length and width, it's 1204 and 602. So it's not a round number. 1204 and 602. So this was one BOM export, this would be for finished goods. So we can see the finished length, width, and thickness. I'll bring up the second bill of material. This is a cutting list, where if we look for that same name, top, we see there that the length and width is 1200 and 600, but we have left and right covers, so we have edge banding on it, and we also have back cover. So the left and right accounts for the 4 millimeters in extra length, and the back cover is accounting for the extra width. So it separates out and it knows how to account for the thickness of things, specifically in this case, like edge banding. And these are customizable. You can customize the templates to change the output and what is shown within these templates. Drawings, we spoke about drawings being automated. So you have predefinable templates that you can set up. And this then automates the drawing creation. The benefit of this is that it creates a consistent and predictable output. So here on the right-hand side, we can see the autoplot settings. If we're looking at assemblies and arrangement of views, we can set which views we want included in the drawing. So in this case, we have our front base view, and we have side elevations and an ISO view enabled, as well as the spacing between them. So you can go through those settings and configure what your drawing should look like. So this is giving you consistent and predictable output, so that when your drawings make it to production, guys on the production floor are receiving the same thing every time. They don't have to come back and ask questions about where's this, where's that. It is consistent and predictable in the output. It also includes important woodworking notes. So we'll see on the next slide here for hole dimensioning. So we have notes specifically for hole dimensioning, but also it can include notes for grain direction and edge banding. So we'll see in the next image here, we have our grain direction indicated by the red arrow pointing to the right. That is also your origin for CNC, or should I say your X and Y axis for CNC. Origin would be bottom left-hand side over here, where all the measurements are taken from. And we can also see that there is edge banding F01 on this front edge of the panel. And there is also a side view with notes on holes that are drilled into the side of this. So all of this that you see in this image was automated and put in by the program, not by the user. And so it quickly generates a set of drawings with just the need for the user to go and check that everything is laid out correctly and readable. You know, maybe this D and C hole notes here could move so that it's easier to spot them. But those are going to be the minor tweaks that would be required. Then moving on to the CAM technology, this works in a similar way, where you automatically, or where you create you predefine your toolpaths that are required, and you can also predefine the order of operations. So if you need to do all your drilling first, and then do your pockets, and then after that groove and cut out the panel, you can set that priority. So you predefine your CNC setup, and you can run through that automation of creating all those toolpaths. And then once again, you can access each part and then access those toolpaths and manually tweak anything if required. It also has tools built in for nesting. However, this nesting is specifically for nesting CNCs, but there you can create, you can see on the right-hand side here, the board with the nested panels in it. And it also understands woodworking, grain direction, specifically where to put grooves and pockets and dowels. It understands the process required and finds those features according to those processes. And it supports most of your popular woodworking machines and CNC software. So it can output formats for Beastworks, Woodwork, various other programs. So that is your CAM section of that. And just to tie this up, how does it compare to designing purely in Inventor? This is data from the developers, from customer surveys. If they look at designing with Inventor, that's about 10% of the time to conceptualize the model, 40% to actually complete in 3D modeling, and then half the time, 50%, is actually just preparation for manufacture. So that would include outputting of all the drawings, outputting of all the CAM programs, making sure the CAM is sorted, the drawings are sorted, now you can manufacture. Design time with Woodwork for Inventor, they're looking at a 5% time to conceptualize the model, 20%, so cutting down from 40 to 20% to actually do the 3D modeling, and cutting down a huge 30% off of the preparation for manufacturing because of those automated processes. And so the overall time saved, they're finding, is at about 55%. So time to jump into the demonstration. I have a sample set that is included with Woodworking for Inventor, and we spoke about the spatial planning up front. And so in this case here, if we look at we're looking at a kitchen, a little kitchen in a flat, and these blue boxes would represent where the cabinets would go. So you can sit with the client and you can modify the layout. You can say, okay, we want certain cabinets here on the left-hand side. We want drawers here in the center. We want the kitchen sink to be here, just to the right of the drawers, and right on the end, a large refrigeration unit or broom cupboard. So you can sit with the client and create this conceptualized space, chat with them. And once that is done, you can then start to add in the details. So that there generally would be exported. This is a multi-body solid. So each of these solids that you see, change our selection here, each of these that you see is a solid, separate solid body. And each of those will give you a cabinet carcass at the end of the day. You can see some of them have faces, drawer faces, or drawer faces on them as well as we have inside here drawer skeletons for drawers as well. You would generally go through the make components process to export those multiple bodies out into an assembly. And for time's sake, I've got this done already and really added in some plinths and backsplashes and countertops just to give a little bit of, just to give it a little bit of an idea of where we're going with this. So looking at this, you can manually now go into your woodwork design and start to add panels to these. So let's say I want to create a panel there on the top right hand side. Oh, sorry, I want to create that cabinet on the top left hand side there. I'll do that here in the concept. So in that spatial planning layout area, we can do skeleton dress up here. And the skeleton dress up is essentially now adding those panels to the skeleton. So we can choose the dress up option, select which of those skeletons we want to dress and add panels to, and then it limits your selection to that specific solid. So now I want to dress this up and give it sides and a back and top and bottom. And so I've selected those 5 faces, all the arrows point inwards, and I'm going to add that thickness, let's say material thickness of 16 millimeters inwards. So I'll accept that. That then creates those panels. And from there, we could go ahead and use tools like your clone, trim, and miter as shown in the presentation. So just a quick look at trim. Grab the side panels here, these 2 side panels we want to trim, and then I can actually leave that like that if I wanted to, and it would trim any overlapping geometry off of those side panels. However, I do want it to go all the way to the back. So in this case, I'm going to choose the select bounding components, and those bounding components will be the top and bottom. So the side panels will be trimmed to fit within the top and bottom panel. I'll hit apply, and then it trims it, and we can see now, if I highlight that side panel, it now sits between that top and bottom. If I pick the back panel and nothing else and hit apply, it will be trimmed to fit within that. It'll be trimmed to fit within that model. So yeah, if I just switch off the visibility of that skeleton, we can now see that model. Just change my visual style here to edges. And we can now see that cabinet within there. Clone option allows you to pick a panel face. It will clone in the direction of that face, and it will clone the panel in the direction of that face. And you can choose your offset. So if I want the shelf to be 300 high and that panel to be 16 millimeters, I can input that information in there, and it will create that panel cloned up to that height. Now, that is not a copy of the existing one. It is a new body. So I can go and I can actually trim that now to fit within the cabinet. So there I now have that panel fitting within that. So you can quite quickly and easily reuse existing panels to create new panels. Now this is nice for custom cabinetry where you don't already have a pre-designed carcass to place in there. And if you already have a predefined carcass, you can use iBoxes to place that predefined carcass in. So I'm going to go here into the sample library. I'll go up to iBox and choose Insert. And I'm going to go ahead and place components from the iBox library. They do have some sample kitchen options. I'm going to go with the wall cabinet. There's a dish rack option. And I'm going to choose that predefined cabinet or that pre-built cabinet to place it in. Now what iBox does is it creates a copy of that cabinet. So it will actually copy that entire assembly, create a new assembly of that cabinet, which will then be resized to fit the space which I will choose. So I'm going to leave those settings at default. Hit OK. And I will then, once that's finished copying, place that box in. Okay, so that box has been copied. Here it is in the model. We can see that it's been brought in. And I'm now going to choose to place this into the existing spot above here. So I'm going to choose skeleton box. And I now have a list of faces I need to choose. So top, at the top of the box, should move that up to the top. Front, when I pick the front, that box will swing around and be positioned facing the correct direction. And then I need to choose the right-hand side. So I'll pick the right-hand side of that skeleton box. And that cabinet is then moved and placed into that position. So I can now close that off, and I have the cabinet sitting there in its required space. So I can hide the rest of that, and we can have a look at that cabinet sitting in there. I'll bring that back in. We can see how it fits with the rest of the boxes. Now, if the customer decides they want to put a wider basin in, that's specified by the width here of this box and that box at the top. We can go and edit our dimensions. Let's say that's 600. Let's say maybe they go with 700, shift all the cabinets up. Maybe let's just change the drawers to 500 to shift that back. We'll finish sketch, and that top cabinet is also based its width on the bottom cabinet, so we see it has updated. Back into the assembly, we can see that that box is now slightly bigger. We can use an option called RBox Refresh, and that will then refresh the RBox. If you just click refresh, it will do all the RBoxes in the assembly. Alternatively, you can pick a specific RBox and refresh only that one. So I'll do that here in this case. And that RBox updates, and we now have that new RBox in there at the new updated width. And so it's quite quick and easy to make design changes within the process of actually designing. Customer always comes back and says, oh, but I want more space here, less space there. It's easier to change those spatial requirements once those components are in. Okay, so that would be the placement of RBoxes. This RBox actually has existing hardware in it, so this was brought in. If I open this up, this RBox is a complete construction. There's no more work required here except for putting doors on. But we can see that there's a shelf. We have our shelf stud and holes drilled for spaces. It's also put together with a system over here with the hardware. And so all of that is predefined inside of that cabinet. So we could repeat the process and add multiple cabinets in. If we want to add hardware in, we should just go back to this assembly here. If I want to add some hardware in, let's say to this cabinet over here, we have the option here called joint, and we can choose attach and browse to the library and find some hardware. So let's say, let's go with Japanese joinery. Go with the shelf holder here, and I am missing one thing to put that shelf holder in. I need a work plane. Okay, I can use the underside of the shelf for now. So I'll attach in that shelf holder. So we go to that library, holders, shelf holder. And this is a R part, so we can choose information to include or exclude the cap. So that's the cap that will hide the holes that are not being used. And how many do we want? So we can choose how many holes we want. So let's say 5 to add extra adjustability. It's okay. And then you've got your options. So sideboard plane. So we'll pick the sideboard plane, the shelf bottom plane. And this is actually what I don't have is the axis plane. So this will be how deep it is into the model. So I'm going to just pick the front here, and we can see that it's inserted on the front there. If I had a work plane further back, I should have used that. And but we can see here now that that is inserted into the model with the specific setup that we chose. Now you can do this multiple times. So if I actually delete that one and put in a work plane, repeat the process very quickly. So the work plane there. and we can reuse the previous setup. So choose that one. And we can see that it's placed in there. Now, our mode, we can actually do multiple instances of that, so they'd only put one in. If I do multiple instances, I will pick two sides, and let's do both axes. And so doing that has added in all four of them in one go. So it's quite a quick process to add your hardware. From there, bill of materials, if we want to extract a bill of materials, it's quite easy to go to your Woodwork Design BOM report. It's going to pull out all the information it requires, and then it shows you a bill of materials. And so here we can see we've got, this is what a body group 01, that's the back panel. If we look at the right panel, it's broken down into its MDF as well as PVC edging, and that breaks down completely there. I've already exported this one to Excel, so I can open up its Excel bill of materials, and that option would be over here, just to output to Excel. And this is the template that is output by default. So we have product structure, shows you information with regards to how the product is put together. Essentially, it's complete bill of materials. We can go to a complete parts list with quantity, length, width, thickness, and that is the completed component. So that is the finished size. Then there's a cutting parts list with the cut size as well as where your edge banding is put on. The material summaries for total amounts of board used, and there's also material summaries by product. I only have one product here, which was the wall cabinet, and there's the amount of material required for that wall cabinet. Okay, so that gives you an idea of the capabilities. I could go here and do a auto plot, select the template file that I want to plot to. So I've just got to, so that would be editing the template. I want to do that. Need to pick on that one, and you can choose from a list of existing templates or take an existing template and modify that template. So if I want to have each component into a separate file, or parents to separate files and children to different sheets, you can choose various options to output here and set your save location. And I'm going to start the plot, and it will now generate all those drawings for this assembly. So I just sit back and watch the progress bar. So this will auto plot out all of the parts and components that are within the active assembly. So if I wanted this to be a bit quicker, I could have just opened up the dishwashing rack, the cabinet with the dishwashing rack in, and done an auto plot on that. Could have gone a bit quicker. This is about the time you go and have a cup of coffee. I also do have two cabinets that the visibility is switched off, so it will also be doing those drawings as well for those cabinets. And there it is, it's done. So if I now go to open and browse to that location, kitchen design, we can see there's the subfolders for the eye boxes that were placed in. And if I scroll down here, we can see the different drawing packs that were generated. So if I take the hanging dish rack, there's the main drawing. Open up that one, and we can see the drawing for that needs a bit of tweaking in this case. And let's go to the dish rack to children, and we can have a look and see that we've got our title block and we have our drawing with the edge banding, grain direction, all that indicated on here. And this has got a sheet per panel. So we can go through and essentially just tweak the output of each of these. Okay, so that is as far as I'm going to go with the demo. I think right now we can switch back to the presentation. Just for a quick summary, we are running towards the end of our time. So in summary, Woodworking for Inventor is a specialized program giving you specialized tool sets for woodworking. It allows you to create furniture models quicker and easier. It allows you to fit models into custom spaces with the use of eye boxes. And it focuses on multiple configurations. We didn't do any hardware replacement options here, but it allows you to configure a standard item quite easily with that hardware and material replacement. Also helps with bill of material management, the auto plotting of drawings, auto generation of CAM, and it complements Inventor's already powerful tools such as iLogic and iPart. So, Woodwork for Inventor, you have to buy Inventor, you buy Woodwork for Inventor. It adds on to that already powerful package of Inventor. And so you still have all of that functionality available to you. So if you're doing bespoke shop fitting and you need to do framework, steel framework, you can still use Inventor Frame Generator, but you then have all that added power of Woodwork for Inventor. And just to add a note on the summary here, Woodwork for Inventor is great for companies that do large volumes of, let's say, office furniture, household flat pack furniture, kitchen cabinetry. If you're doing large projects with lots of kitchen cabinetry, this will speed up your turnaround times on that. Shop fitting, once again, you can have your standard shop fitting units for a specific brand, and each shop requirement changes with the size of that specific piece of shop fitting. So that can be modified as required. So it speeds up that design process. And then we'll move on to questions. Do we have any questions in the chat section? Nothing's come through. So we will end. Yeah,